Hey everyone, so let me ask you a question. Suppose you are giving an exam and you get the result. So suppose there is a subject called linear algebra in which you got 67 marks out of 100, and suppose there is a subject called English or any other subject where you get 89 marks. The question is, in which subject you have performed better? Can you say directly that you have performed better in English? Well, indirectly answer is no. So how to conclude that? Well, the answer lies in standard normal distribution. Now see, these both are different things. They're in the different world. Linear algebra is a different subject, English is a different subject. I can't compare the marks of these two. But still, if I want to see in which subject I have performed better, I have to bring them in the one world. And that world is nothing but standard normal distribution or the Z distribution. So I will come to this, we will see what is the answer for this. We need some more data actually to conclude this, but we will come to it by first looking the concepts. So let us see what is the agenda for today's session, and then let's come back to the answer for this question. So the agenda for today's session is, first we are going to see that if X is a normal distribution, then the Y distribution is also a normal distribution. That means if you do a linear change in X, then the linear change in X, which I am calling it as Y, is also a normal distribution. Okay, so the linear change in variable of a normal distribution is again a normal distribution. What is the second point we are going to see? Standard normal distribution, or sometimes also called as a Z distribution. One of the very important distribution one should study while playing with statistics. So we are going to see its importance. We are going to see very few important points, and yeah, so that's also, that's what the agenda is. So again, same as earlier lecture, this will again be a theoretical or the conceptual lecture. In the next lecture, we will see some examples. So let us go for the first thing, that is the linear change of variable is again a linear change of variable of a normal distribution is again a normal distribution. Okay, so what do you have? You have X is a normal distribution with mean mu and the variance sigma square. Our claim is your Y also follows normal distribution. Question is, what will be my mean? What will be my variance? Okay, now let us try to see this. So what do we have? So here I am going to use the concept of CDF and PDF. So I have already recorded those lectures earlier. Link you can find in the description. Okay, now what is my capital F? Capital F is always reserved for CDF, cumulative distribution function, small f, probability density function. So let me take a CDF for the random variable Y. So just to specify, this is F is for Y random variable. What is this? Probability that Y will take the value less equal Y by definition. But what is our Y? Our Y is nothing but AX plus B. So I have AX plus B less equal Y. So this implies your less X is nothing but less equal Y minus B by A. But what is probability that the random variable X will take value less equal something? It is nothing but the CDF for the random variable X, and here you will have Y minus B upon A. So this is a CDF for random variable X. Okay, so this is the relation we have between the CDF for the random variable X and the random variable Y. Okay, now what can you say about the PDF for the random variable Y? We have seen earlier that the PDF is nothing but the derivative of a CDF. But what is this? This is d by dy. What is CDF for Y? It is CDF for X, but instead of small x, we have Y minus B upon A. Now you have to differentiate. Now this is a function of Y minus B upon A. So when I differentiate with respect to Y, what do I get? So derivative of capital F is small f, fx. I mean, this is just to represent, see, I can also write f and f, but then don't get confused, for this is the CDF for Y, this is the CDF for X. And when I take this derivative for CDF of X, I get the PDF of X. So this is nothing but fx of Y minus B upon A into, by chain rule, derivative of the inner term with respect to Y. So it is nothing but 1 by A. So I want to find this PDF for Y. It is nothing but PDF of X with this as an input, Y minus B upon A. But we know what is the PDF. A PDF, if you recall, it is given by 1 upon root of 2 pi of standard deviation e raised to minus of x minus mu square by 2 upon 2 sigma square. So what this will be? So therefore our fy of y is 1 upon a. What is fx of y minus b upon a? 1 upon root of 2 pi into sigma e raised to minus of. Now in place of x, what will you write? In place of x you will write y minus b upon a minus mu the whole square upon 2 sigma square. So what is this? This is 1 upon root of 2 pi. I am writing a sigma together. E raised to minus of y minus of a mu plus b. I am taking minus outside. Whole square upon 2. This a will come here. So 2a square sigma square. So you can see this is the PDF for the random variable y. And what is the mean over here? So y follows the normal distribution. What is the mean? A mu plus b. And what is the variance? A square sigma square. A square sigma square. So if your x is a normal distribution, then ax plus b is also a normal distribution with mean as a mu plus b and variance as a square sigma square. What will be standard deviation? Plus minus a sigma. Okay. So for example, if I say that x follows the normal distribution 3 and 4, question is, and if your y is 7x plus 9, question is, what is the mean and the standard variance for the random variable y? So here your a is 7, your b is 9, your mu is 3, your sigma square is 4. So a mu plus b, 7 into 3, 21, 21 plus 9, 30. A square, 9 into sigma square is 4. So don't take 4 square, this is sigma square. People usually make these mistakes, that's why I am stressing the point. So a square is 9 into 4 is 36. So if you have a normal distribution with mean 3 and variance 4, and if you are doing this change of variable, you again get a normal distribution with mean 30 and the variance 36. So I hope the proof is clear. If you have any doubt in the proof, you can ask me in the comment section. Now let's go for the second point. Okay, so now we are going to talk about standard normal distribution or the Z distribution. Now once you have a normal distribution, you can always convert that normal distribution into a standard normal distribution. Now but you can ask me that once I have a normal distribution, why to study one more standard normal distribution? What is the use? Well, there are plenty of uses. Few of them, like, see, first of all, what is the standard normal distribution? So I will call Z to be a standard normal distribution if it is a normal distribution with the mean 0 and the variance 1. Then if you have a normal distribution with this mean and this variance, then we call such a distribution to be a standard normal distribution or the Z distribution. That's why the variable, random variable Z we are using. Okay, and we also know that when you have this as a mean and a variance, we have seen in the last lecture that this PDF is given by this Gaussian function. Okay, so this is the bell-shaped curve you get. So this is what we have. Now what are the importance or what is the importance of this topic, standard normal distribution or the Z distribution? The first is very simple. Simple as in, see, 0 and 1, these are always nice number. I mean, except your marks in the exam, but otherwise when you want to play with numbers, these are always very nice numbers. And you can see the PDF is also easy. Easy as in, as compared to the standard general PDF. 1 upon root 2 pi sigma e raised to minus of x minus mu square upon 2 sigma square. So that is complicated as compared to this. So you can see the first thing is the simplicity. In standard normal distribution, mean is 0, variance is 1, your PDF is simple. That's the first point. Second point, when you want to compare the things, like the example which I told you at the start, that if you get some number of marks in one subject and some number of marks in another subject, how to conclude in which subject you performed better. Okay, so simply looking at the marks, you can't see that okay, in this subject you have performed better. You should have something called as standardization, then only you can compare. You have to bring everything into the one world, and when everything belongs to the one world, then only you can compare the things. Okay, so for comparison things also we need standardization or we need Z distribution. Another third important point I would say is See, calculating this is not easy. So in the exam, what we do is like we give you the tables, and from the table, you see the table and try to answer the question. So in the exam, they will always provide you the table for standard normal distribution with 0 and 1. Because see, one cannot provide you infinitely many tables, right? Because for a different data set, you will have a mean, you will have variance. Again, you change some points. For different data points, you will have different mean, different variance. So there are infinitely many distributions with mean and variance. We can't keep on providing each and every table. So we have to do some kind of standardization, which is this. And it's easy to play also, right? Because if I give you a data set whose mean is 15,17,482 and the variance is 2,36,000. And if I give you another distribution with mean 0 and variance 1, then with which distribution you will play? Obviously with this distribution you will play, because the numbers are very easy. It's easy to play manually as well as for the computers as well, because here the memory it will take is less, whereas compared to those big numbers. So like this, there are plenty of uses. That's why one studies standard normal distribution. Now the question is how to do this conversion. Okay, so suppose if you have x and z, x random variable, z random variable, you have the data points x1, x2, x million, x trillion, whatever. You have a data points. How do you convert it into z distribution? What you do is your z variable is nothing but x minus mu upon sigma. So once you have a data set, you find its average, mean, you find its standard deviation. From each point, you subtract the mean and divide by standard deviation. Subtract by mean, divide by standard deviation. You keep on doing this. What you get is a new distribution, because if this is normal distribution, this is also normal distribution. Yes, because what is this? This is 1 by sigma times x minus mu by sigma. In short, your z is nothing but 1 by sigma times x minus mu by sigma. This is a linear change in x. And just now we saw a linear change in a normal distribution is again a normal distribution. So this is again a normal distribution. Okay, good. Now what can you say about the mean and variance for this? Now we know the formula. So what is the mean for the random variable z? We saw earlier, if y is ax plus b, then what is the mean? It is a mu plus b. What is your a? Your a is nothing but 1 by sigma. So you get 1 by sigma times mu plus, what is your b? Minus mu by sigma. So plus into minus is minus, mu by sigma. Answer is 0. So mean of this distribution is 0. What was the variance? The variance was nothing but a square sigma square, right? So a square into what is variance for this? Sorry, so what is my a over here? 1 upon sigma square into sigma square, which is 1. So this was a normal distribution. We are obtaining z by a linear change, which is again a normal distribution with mean 0 and the variance 1. So now you have a new set of data points. Good. So we have done this transition from the world x to the world z, and mean and variance are 0 and 1. But now the question is this a nice transition? Nice transition as in what? Now if I want to find a probability between 2 points over here, that means if I want to find the probability of x1 less equal x less equal x2, question is this equal to the probability in the z world? So like for x1 we have z1, for x2 we have z2. So for this xi's we have zi's, and if I want to find the probability between two data sets, question is that equal to, is it same as to find the probability between the data points in the z distribution? If these two are equal, then only it's worth playing with this data set. If I'm getting a different answer, there is no point in playing with this data set, because this is giving you different answer, this is giving you different answer. So what's the point of doing the transition? Okay, but we get this to be equal to, that means the transition is a good transition. How to prove it? What is this by definition? It is 1 upon root of 2 pi into sigma integration x1 to x2 e raised to minus of x minus mu square upon 2 sigma square dx. What is our z? Our z is x minus mu upon sigma. So what do we get? This is equal to 1 upon square root of 2 pi integration. When you put x1, so what is you get z1. What is z1? x1 minus mu upon sigma. What is z2? x2 minus mu upon sigma. So I have integration from z1 to z2. What is this? E raised to, oh, so I missed a sigma over here. Here minus of x minus mu upon sigma is z. So 1 by 2 z square. What is dx? It is sigma dz. Sigma dz. Sigma goes away. So what you get? 1 upon root of 2 pi integration z1 to z2 e raised to minus 1 by 2 z square dz. But what is this? This is a PDF for a normal distribution with mean 0 and variance 1. So this is nothing but this thing. Because what is probability of this? This is probability is nothing but 1 upon root of, it is this only. Instead of x you have z. Because this is a standard normal distribution with mean 0 and the variance 1. So probability of this is nothing but 1 upon root 2 pi integration z1 to z2 e raised to minus z square by 2 dz. And that's what we are getting over here. So when you try to find the probability of this, thanks to this substitution, we are getting this probability. So thus the upshot is, whenever you have a set of data points, you always do the normalization, or you always do the standardization, or you always do the unitarization. These are the words people uses. You get the z distribution. The z data points, this is called as x points, this is called as z points, or sometimes also called as z score. Okay, so once you have x data points, you find the z data points. Now z data points, that means the random variable z is a normal distribution with mean 0, variance 1, and this is a nice transition. That means if you take any x1, x2, and if you want to find the probability that the random variable x is taking the value from x1 to x2 is same as the probability random variable z will take between the corresponding variables of x1 and x2, which is z1 and z2. So this is a nice transition. Okay, so let's come back to the original question. Now this was the linear algebra, you got 67, English was 89. Now as I said, you need more data. So suppose the mean for this subject is 52, that means average, you collect the average of all the students, average is 52, variance is 3, sorry, the standard deviation is 3. Here average is 79 and the standard deviation is 5. So now let us try to find the z score. So x1 is this. What is the z1? So this z score is for linear algebra, x minus mu upon sigma. This is the z score for English. So you can see here you are having the higher z score than this. That means you have performed better in linear algebra. Okay, and that's why we do relative grading and not the ordinary grading. Okay, we have to make sure you consider all these parameters and then only you conclude how you are performing. Okay, so if I want to explain you this with the help of a diagram. Now suppose this is the distribution for linear algebra, this is a distribution for English subject. Now you can't compare them, right, because these are different distributions. So what we did is we found their z score. That means we converted both of them to standard normal distribution or the z distribution. Now here you have a different mean and different variance, but here the mean and the variance is same. So now they're in the same world. So at one place you got z score to be 5 and at one place you got 2. So this is the mean. So obviously you are away from the mean. That means you are having more marks from the average students. Therefore you have performed better in linear algebra as compared to English subject. So that's why we need one world where you can compare the things. So I hope this is clear. If you have any doubt in this part, you can ask me in the comment section, or in general any part, you can ask me in the comment section. Now when you get a positive z score or a negative z score, what can you say about the given standard distribution, given normal distribution? So this is a normal distribution, you convert into standard normal distribution or the z distribution. So here the mean is mu, variance is sigma, standard deviation is sigma. Here the mean is 0, variance is 1. Now if I am getting a positive, this is my z and this is for x. Now if I am getting a positive z score, so like this mean, it was here, it became 0 over here. Now if I am getting a positive z score, that means positive z value, that means you are lying on the right side of the mean mu. If you are getting a negative z score, that means your data set is on the left hand side of the mean mu. And if you're getting a 0 z score, that means your x points are nothing but the average value. Your x is equal to mu. Okay, so if z is greater than 0, that means your x is greater than mu. If your z is less than 0, that means your x is less than mu. If your z is equal to 0, that means your x is equal to 0. So this is another interpretation you can do about the data points of the given normal distribution from the z score or from the standard normal distribution. Okay, so that's all for today's session. So I have told you enough of the theory and the motivation on why to study z distribution. In next lecture, we will take examples on normal and the z distribution. And if you have any doubt in this, do ask me in comment section. And if everything is clear, do not forget to like, share and subscribe. Thank you.